Hi everyone, I'm Hubert Sablonnière. I'm a web developer at Iliad Conseil in Lille, and today I want to talk about Jurassic Park. I love this movie. I can still hear the T-Rex in my nightmares. And when it came out in '93, I was still a bit young. So that's why I went to see it with my parents on a Saturday afternoon. And back then, when you wanted information about the movie, the pitch, the runtime, the show times, you had to go buy a newspaper. So my parents and I had to take a round trip using the car to the news dealer. Going there, buying the newspaper, coming back. It took around 20 minutes and it cost us 5 francs. 22 years later, the web has completely changed. We are all connected. And I'm still movie addict, so every week I visit my favorite website to check the movies in my local area, what are the show times, etc. And when I do this with my web browser, I'm doing around 20 round trips with the server, and I'm obviously using the internet. And it takes around 1 second with a good desktop connection, and it costs me nothing. So we could easily conclude the web is far better than a news dealer. But in reality, it's not that simple. I mean, back in '93, when my parents decided to go watch another movie the same week, they did not need to go back to the news dealer. The access to the information is instant, because they know the business rule. I don't know in Belgium or anywhere else, but in France, the show times are valid from Wednesday morning to Tuesday evening. So once you have the newspaper, you already have the information. And I think it was good old times, right? Right now, when I go again, visit a website about show times the same week, I'm doing a bunch of round trips with the server. Round trips for HTTP are not the only one. I also have to do some radio if I'm on mobile, to do some DNS, TCP, TLS, etc. So basically, I think it's a bug. I think it's exactly the same as going back to the news dealer just to buy the same newspaper again, or maybe just to check that the informations are still relevant. So I often hear, nah, it's 2015, we're all connected. The Internet of Things, man, you know, smartwatches, smart phones, smart fridges. Well, I don't agree at all with that. When you say that, you completely forgot about Murphy's Law. And people saying that are the same that code stuff like this. So, yes, I have a 4G plan. I have a fiber broadband in my apartment, but real life is not simple as airplane mode versus full internet speed. Actually, having no connection is quick and simple. Please, server, give me that website. No, you have no connection. It's really simple. The problem is when my laptop, my mobile, are saying, hey, you have signal, you have Wi-Fi, but I don't. And I don't trust them anymore. There's a lot of reasons and cases where they lie to me, and I suffer from my connectivity. When I go on holiday, I think you do the same. Sometimes I use Netflix, and I completely bust my data allowance, and my phone says 4G, no problem. But I'm more in a 56K modem era, you know? So the other day, I was doing a performance audit for a client, and around 12:15, I'm like, guys, what's going on with the Wi-Fi? Oh yes, Hubert, we forgot to tell you, just behind this wall, there's the kitchen. And, you know, during lunch, people kind of want to eat, so they use the microwave. And now you're screwed. It's a true story. And then there's the classic bar moment when you're with some friends, you need Wikipedia to prove they are wrong and you're right. It's always in those cases that you have 1 or 2 bars of signals, but nothing loads. Who here reads RSS feeds? Yeah? So like me, when I'm reading some RSS feeds, and the only free spot is often the one that is really too far from the Wi-Fi, you know. It drives me really, really crazy because you need to optimize this time, you know. So actually, I call my mobile plan Schrödinger's plan, the quantic and fast slow mobile plan. We need to consider everyone as this plan, especially the users of the web applications we are building. All of them don't have 4G or fiber. They sometimes live in areas and countries where it doesn't exist. And if they are lucky enough to have these, they are still getting slapped by Murphy's Law every day. So our users waste too much time waiting for widescreens to become awesome. Or worst, they don't have a connection at all, and it's the Jurassic Park effect. It also works with Firefox. You just have to be a little, have some imagination, you know, to remember the T-Rex. A good way to resolve that is to use offline first. It's a really, really interesting pattern, and the 2 words are really important. So the goal is not to focus on people who don't have a connection at all. The focus is that in the first time, you need to consider that your user is offline, and you will display all the information you can without a server. And then, after that, you can enhance the display with additional information from the server. There's a lot of information on their website. It's really interesting. And actually, you really need to consider that every user you have subscribes Schrödinger's plan, and that network connectivity is a feature like any other. GPS location, touch, webcam, you already test if the user has or has not these features. So let's do the same. Offline First is here to help your users, their batteries, their data plan, but also your servers and your bandwidth. And we don't really think about that, but when my laptop says 100% Wi-Fi and my modem has the perfect speed access to the internet, the website I'm visiting still needs to load. And recently, anyone uses Pocket? Recently, Pocket went down, and their website was completely unusable, but their native iOS app and Android app was working great in offline mode. So it's exactly thanks to that kind of example that people tend to believe that a native app is better than a web app. Connectivity, push notifications, OS integrations, and of course performance. And I love the web, so it really bothers me to display that kind of information. And it's not because native can do better that it always does. There's a lot of anti-patterns, and there's also good examples. The Twitter app, for example, you open the app, it displays the last tweet you visited instantly, really fast. And while you're reading something, it goes to the server to check if there's anything new. If there's anything new, it's okay, it will load. Please do not scroll and disturb the user. Just display something's new just up, but don't push it into his face. And if there's nothing new, it's okay. You can still use the app, so nothing breaks. So since 2009, we can try to tackle offline first on the web using something called AppCache. It's in the HTML5 spec, and today the support is pretty good on modern websites. So how does AppCache works? Has anyone ever tried? Yeah, you're still alive. Well done. So AppCache, you reference a manifest in your HTML file. And in that manifest, you have to put a special header, cache manifest. You also put a version number. We'll see that just after. And there's 3 sections. So the first one is cache. You list everything you really need in your application. It's the shell, HTML, CSS, images, etc. Then you have the network part. Here you list everything that needs the network. But if you forget to list something, or if you forget to put a star, it won't work. So by using this technology the wrong way, every request that tries to go to the server will fail. So don't forget the star or to specifically list stuff. And then there's a fallback section. So for example, here, if I can't manage to retrieve list HTML, I can display no connection HTML instead. So on the first load, classic loading, it goes from the network, it displays on the page, and while you're reading the website, the browser has stored all the files listed in cache, etc., in the app cache. And on all the second loads, it goes instantly from the app cache. No network, no server access. It's the quickest way you can display a page. Awesome, right? But if I visit again, and it comes from the app cache, how can I display something new? And how can I update that? It's strange. So imagine I modify a CSS file. The browser, while it's displaying the information from the cache, is actually asking the network, the server, do you have something new? But instead of saying, is the CSS new, is the JS new, etc., it just say, yeah, you know the manifest here, has it changed? Okay. So that's why you really have to put something like a version number to increment it, to specify that a file has changed. That you're starting to see the problems with that technology. So if you're a real developer, you'll use some tools, adding some hashes as comments or in the file names. So the network said, yes, I have a new manifest. Okay, I'm dumping everything in the garbage and I'm re-downloading everything. And I mean everything. If you have the good headers, you won't maybe have too much data in the bandwidth, but you'll still do a lot of round trips. So you feel like an idiot because the app cache has the next version of your web page, but you don't. The page is still on version 1. And at first, it seems really strange. I was like, what the hell? And actually, it's quite logical. And if one of your users is reading something, filling up a form, you really need not to interrupt them. They are working, they are concentrated, so don't bother them with something. At least do it with some code. So in the app cache, you can listen for an event called update ready. And if you receive that event, if the callback is called, you can maybe ask the user, hey, I have a new version. Do you want to reload the page or something? The app cache is very declarative, so you can't really program it, and you can't list all the files that are in the app cache. You can't add one file without re-downloading everything, idem for update and delete. And AppCache, actually, it's the only technology you need to display a page without a connection, but it's not the technology you deserve. That's why you can read a really, really good article about AppCache. And in the conclusion, Jake Archibald advises to use it at its strict minimum and to rely on other storage APIs for the rest. And it's exactly what Devoxx does. Someone here uses Devoxx. It's a great website, instantly fast documentation about a lot of stuff, Git, HTML, Express, Angular, Go, etc. So it uses the AppCache for the website shell, and then the local storage for the list of the different documentations, and the IndexedDB for the contents of the documentation. So with that, you have an offline-first web app, website, that displays documentation at the moment you need it without waiting whether you have a good connection, a bad connection, or no connection at all. Confucius, yeah, said, okay, it's exactly what happened to AppCache. The spec was written at a time where writing APIs were written with a high-level aspect. So they tried to resolve one problem with a simple solution. And right now, since the Extensible Web Manifesto a few years ago, we start to see more low-level API. And it's like, take the fish, take the rod. You'll have to work to get your fish, but you'll be able to do more, to accomplish some more stuff. So that's exactly how the service worker spec was written and started. It actually describes an API, a really low-level API, that answers bad connection and offline situation, but it also opens doors to reduce the gap between mobile and web, native and web on mobile. A lot of people are working on that specification, Mozilla, Google, Samsung, etc. And actually, a service worker, it's basically a programmable proxy inside your navigator that intercepts all the requests between your page and the network. And it has its own cache. Okay, so let's do this again. You have your pages, okay? They come from the network, classic. You add a proxy, which is on the client side. Ooh, scary. And you program it with JavaScript. Super scary. With this, you intercept all the requests that goes to the network. Style sheets, scripts, images, AJAX requests, etc. You can answer from the server. You can create your own responses, but you also can respond from a dedicated cache. And you're in control. You can put whatever you want in it and read when you want. So it only works with HTTPS. Oh. It's actually good news because you control all the pages of your origin. So an origin, subdomain, same domain, same port. And you can intercept any request that goes from your origin to anywhere else, to your own origin, but to some CDNs, etc. So anything that goes from your page is intercepted. So if someone can do a man-in-the-middle attack, I would really be scared to have something installed in my web browser that could intercept everything. So, yeah, HTTPS. And actually, there's a new initiative that should come out of beta before the end of the year. That's called Let's Encrypt. And I tried the beta, which is closed right now, so sorry. But you can't say no to a command line that generates and renews SSL certificates, valid ones, everywhere, for free. I mean, how awesome is that? So how does it work? Service worker. So first, in a script that is on your page, you check that the API is supported. It's really important. And then on Navigator Service Worker, you call register. And that's your way of saying to the browser, this file, swjs, is my service worker script. So your browser executes the script in a thread that is independent from your page. It's really important. So it doesn't have DOM access. And it's asynchronous, so it returns a promise. And if everything goes great, you have a registration object. If anything goes wrong, you have an error, like, you know. So everyone is familiar with JavaScript promises? Yeah? It's a really right moment to learn about it. There's lots of good articles. It helps a lot with dealing with asynchronous stuff and composing asynchronous calls, chaining them, etc. It's now part of the JavaScript standard, AS6, and it's supported in modern web browser like Edge and Node.js, etc. So no need to add some libraries, and it's really awesome. And you won't be able to skip the train because they are everywhere in the service worker and cache APIs. So on the service worker thread, you have no access to the DOM. So the global window object, it doesn't exist. But you have a global object called self, and with it, you can listen to events. And the more interesting one is fetch. So with that, you see all the requests that are made by your pages. Scripts, images, Ajax calls, etc. And you can respond with anything you want. You can create your own responses. It's not really useful every day. What's really great would be to answer with something stored in the browser. So there's a new storing API, which is called the cache. And it describes in a second part, it's described in the second part of the service worker spec. And basically, it's a map that matches request and response objects. And it has nothing to do with the HTTP cache, but the matching between a request and a response regarding headers, etc., pretty much follows the same rules. So when I intercept a request, I just have to find in one of my caches a response that matches with caches that match. And I don't need the network to do that. And because it's programmable, I can decide, well, everything that goes to the API will come from the server, and for anything else, I will try in the cache. So how will I do some HTTP request to the server? Any ideas? No? You're probably thinking about XHRs. Well, you can't. First, the name is complete crap. There's lowercase, uppercase. We've been using it with JSON for ages, so, well. The real reason is that despite the asynchronous in Ajax, if you have a URL and an XHR, you can do synchronous calls. And you can't have blocking calls in a service worker's thread. Everything is asynchronous. And welcome to the boring old school boilerplate API. I need to put a type. I have some boring callbacks, etc. So we have a new API, the fetch API. So it's a separated spec, It's maintained by someone at Mozilla, and it describes everything for fetching stuff over the network. It also describes the interfaces of request and response that are used in service workers. So let's use the same example. I have a URL, and I just do fetch URL. It's that simple. It works with strings. I can also put some request objects, and it returns a promise, obviously. If you have a response, because it could be streamed, if you want the whole JSON content, you have to call .json, which also returns a promise, and then you have the JSON body you really wanted. And if you have errors, don't forget to do something else than logging it. By default, this API passes do some get, but you can pass another argument just here, and you can do some post and any other method, specify some headers, etc. So it's a good API. So now I can reuse my example and just call fetch with a request object or using the cache. So for now, we've been intercepting requests with a few for a few slides now, and it worked without a connection. So we executed a JavaScript, a script, without a connection. So the browser has stored the script that is used for the service worker somewhere. Kind of sounds like the AppCache and its manifest. So how can we update something? You have to understand the life cycle of a service worker. So on each page where you have a registration, while you do that, while you call register, in the back, the browser tries to install your service worker. And in the script, it executes it and sends an install event. That means I'm trying to install it. It's not done yet. And here we'll be able to do some really interesting stuff. So I can name a cache and list some URLs I always need for my app. And then I just have to say, okay, just wait a little. I'll give you a premise, and if it resolves correctly, you will consider the installation process a success. So I'll give just my service worker, I just open the cache I named, and then once it's open with a promise again, I will just add all the URLs in the array above. So my browser take all the URLs, do some request, fetches the response, and store them in the cache with the matching between request and response. Here, that just returns a promise again. So that's used by the browser to know if the installation is a success. If it's a success, we go to the activation phase. And the first load, the first time you use service workers, you don't really have to do anything here. It comes useful when you update the behavior of your worker. So a bit like AppCache, while you browse a page, and the browser sometimes tries to verify if there's a new service worker. So if there's something new, it downloads it, it executes it, and triggers the install event. That's where you add files. Don't delete files from the cache, and don't update, replace files in the cache. Because while you install a version 2 of your service worker, maybe some pages are opened, and with the previous version, the user may be using this, so don't remove stuff. And that's when, once it's activated, you'll be able to do some cleaning. So before the activation, the browser waits for all pages controlled by the previous version of the service worker to be closed. You have a mechanism to force it. There's some good reason, but in most cases, you will have to wait. So once you activate, you can clean up. Please have some mercy for your user's memory. Okay, so once the activation is okay, the service worker will take control of the next open pages. And as I was saying, unlike AppCache, which has a dedicated event for updates, here you need to catch the fish yourself. So, if you've installed a new service worker version, it's up to you to check the new update and to notify all the open pages that there's a modification. And actually, it's really more powerful than that. You can send messages between your service worker, it's a separate thread, and your pages. So maybe from you send the message using the post message API, and on the registration object, you can access the active service worker and send messages. So, for example, I can decide to force an update once the user clicks somewhere, and I'm sending a message to my service worker to maybe update the cache. On the service worker side, I just have to verify the object is what I want and update the cache. So I can also use post message in very interesting ways. When I intercept a call to the logout URL, I just know the user is trying to log out, obviously. So I can notify all the other opened tabs, hey, the user just wants to shut down, so redirect to the login page or the home page, I don't know. I just have to list the open tabs with the clients.matchall. It's again a promise. And on each client, I just iterate and post a message, hey, the guys just want to log out, so let's do something. And on the page side, you have to listen for messages. And again, if the object from the message is what you want, you maybe have to clear some caches to remove the avatar in the upper right, I don't know. And I don't have to execute code on the page. I'm not forced to do that. I can also make pages navigate to something else in my service worker. So here I'm just saying, well, all the open tabs navigate to /login. So how will we debug all this crap? With Firefox, it's very early. You're more or less coding blindly, but you can see the logs, and you have a page listing all the service workers that are registered. In Chrome, the support is really, really good. So again, you can see the logs, great. You can have a page that lists all the registered service workers. The really important information is the status. Is it activated, installed, stopped, etc. But you have now a really good DevTools. This page was at the beginning, but now we have something in the resources panel. So I'll use a demo website I've built that shows some conference schedules. So once I load the website, on the right, I can see that my service worker is trying to install. So the status is new, and it's just starting. And if I go see the network panel, like any other website, the website loads like it always does. So you can see the normal pages requested, but you can also see some duplicates, because my page wanted / or nextspeaker.io, but my service worker also does. So you can see a small gear on the left of some requests. It just means that these requests were made from the service worker. And here you see a single page app. So if I browse the conferences and the talks on Thursday, sorry, it's the same page. So it's still proper navigation, and in the network panel, I still see requests done going from the network. I went through an empty activation here, nothing new, so it really goes fast. And from now on, all new pages will be controlled with the service worker. And one very important thing is that your browser can decide to stop the service worker anytime it feels so, not during some code execution, but if you want to mine some bitcoins on your user's machine, you won't be able to do that. So if my page wants something new, that's when my browser will want to wake up my service worker and tells him, hey, we have a fetch, what do we do, cache, network, etc. So here it's just activated again. You can verify a service worker controls a page or not, because on the size column, you don't have the size in kilobytes anymore. You have from service worker. It just means that this page is controlled by service worker. You also have the ability to list what's in your different caches. You don't see the content of the response, so it's a bit complicated. And you can debug step by step in the worker, and that's really nice. Okay, so who needs this? Feels like a bit complicated to implement. Do we really need that? I'm convinced that it will be something really used in the next few years, and it's really useful for any kind of website and web app. You take a single page app, desktop or mobile, I don't care. It's the pattern I used for my demo. I cache the app shell, all the CSS images, HTML for the menus, etc. I cache the schedule APIs and avatars once the user visits them, so I don't download everything. It's just as he needs it. And because the avatars depends on the schedule API, like Devoxx is saying me, okay, today there's Hubert, John, Peter, so they avatar these URLs. It's really dynamic, and with AppCache, it would be a complete mess to try either to use the AppCache and trying to list the avatars in it, or trying to use something like IndexedDB to store the binary images. It's really too much complicated, and it's really here that a service worker helps a lot. If you do some transformation on your JSON responses, you can store them in maybe IndexedDB and not use the cache for that. Parlays was a single page app, rest in peace, and this summer they added an offline feature that uses service worker. Users can download talks to watch them later, and they also use some APIs that only works on Chrome, but there's good or explainable reasons for that. You can also, it's also very good for classic good websites doing some server-side rendering. And whether you have JavaScript in your pages or not, think about Wikipedia. Imagine that the last 10 pages you visited are cached. You can then answer directly from the cache when someone visits again. And if he visits some page you don't have in the cache and the network takes too much time to load, you can generate a response containing the list of the 10 pages you have and some message like, hey, I'm sorry, I don't have page foo, but I have this. Are you interested? That's almost what Jake Archibald did as an experiment. I really encourage you to try this demo. There's also a video explaining all the optimization that it did using Service Worker. And it basically does what I explained, but there's no list of 10 last articles. Either you cache everything that is visited, or you cache it one by one with the little button. Recently, I think 2 or 3 weeks ago, The Guardian decided to ship something with a Service Worker. So if you navigate to a page and you really have no connection at all, they are saying, unable to connect to the internet. In the meantime, how about a quick crossword? Nice, no? This technology also opens doors to crazy bullshit buzzwords like this one. And that's exactly what I'm excited about right now. We're in the make shit phase, you know? We'll decide what's best practice and what's really a bad idea along the discoveries. So we are trying ideas, and it's really interesting. For Devoxx France, I tried an experiment. I did a quickie about CSS, and it was 15 minutes of live coding. Everyone here loves CSS, I hope. Yeah. So it's basically a really dumb version of JSBean or CodePen, a really, really simple one. And on the left side, you have a code editor. On the right, you have a live preview of what's coded. And I don't rely on conference Wi-Fi, because you shouldn't. And each time I type a letter, a character in the code editor, I generate a fake response in the cache, I store it, and then I tell the iframe, the live preview iframe on the right, to just refresh itself. It does a get to fetch the HTML and then some CSS in it, and it all comes from the cache. I don't have any network. And it's really the quickest way to do some real feedback, quick feedback, without trying to build a page inside a page. And because it's 2 iframes, I also put the code editor in an iframe, I can open them separately and move them on 2 different screens. And now I have some multi-screen web experience. Mozilla tried some experiments regarding templating. So you do a get in a page to an article. Maybe all your articles on your blog look the same. So why wouldn't you only get the contents and do the templating in the proxy, the service worker? And they find some improvement in performance, and we are still trying ideas. I really like the diff one. Think about it. When you have CSS, you barely change a few characters each time. You change the color or the size of something, but on a 100K file, you just change a few characters. You could do a simple, just a link tag with a style sheet in your page, so it does a basic get, but because it's intercepted by your service worker, you could just tell the server, hey, I have this version, do you have a new version, and can you send me only the changes? And instead of re-downloading 100K, you can only download a few bytes. The problem is, what's the good recipe? Should I do network first, cache first, then network, or I don't know. And it's really a difficult problem. There are many strategies. It depends on your data and your users. There's a really, really, really good article about the subject, the offline codebook. I really like the idea of doing a race. Is there anyone using Windows here? Okay. Do you have an antivirus? Yeah. And have you a non-SSD drive? Okay. The network can be faster than your hard drive. And there's many other ideas. I mean, you could let the server 1 second to answer, and if it doesn't, maybe you just use the cache. You can try anything you want, and it's really interesting. So now, ladies and gentlemen, the question of browser support. For now, it only works in stable version of Chrome and Opera. And Mozilla has done a really tremendous job on their implementation. It's a little bit better than Opera and Chrome, or more advanced, but it's not in stable yet. It's in the dev edition release that you can try today. Microsoft says under consideration. So it means we don't care, you know? And if you follow some Microsoft employees on Twitter, they're interested, but it's not the priority, and because it's something complicated to implement, I think it will take time, but I'm pretty optimistic. Safari. We have no news. Silence. It's not unusual because they never comment on their roadmap. So let's wait and see, but I'm not really optimistic regarding their platform and their business needs. So you can learn more about what's supported in which browser on this website. It's really good. You know about promises, fetch, the cache, can you post some messages, all the stuff that are supported with the service worker. There's no polyfill. Oh, there's no polyfill. It's a great news. It's great news because if someone could hack with just simple JavaScript and do that, I would really be scared. So it's okay. And there's a lot of helpers on GitHub. New ones are coming every day, really interesting ideas. There's a good one by Google. They used it on their Google I/O website. And like other libraries, they bring a router. So instead of making some crazy regexes on your URLs, you can have some pretty decent stuff. And they are also implementing ready-to-use recipes like cache first, network only, fastest, etc. So it's okay if it doesn't work in Safari or Edge. Think about progressive enhancements, and the service workers has been written, the spec, with that in mind. So I like the good old metaphor of the escalator. Don't worry, you've never seen someone stuck in an elevator. When it fails, it's just becoming stairs. And it's the same for a website. In a browser without service worker support, it's just a regular Jurassic website. It works like it always has been since the beginning of the web. I would like to end with the traditional debate, native versus web. There's a term coming up since a few months that's called progressive apps. And the idea is to say, you know, on the PS4, you can download the game, but while it's downloading, you can already play level 1. It's the same. Why do I need to download, I don't know, a 5 or 10 megabytes app on the App Store, and I have to wait just to find out that the app is total crap? So if it were a website, the loading would be instant. I would not depend on someone's App Store or market or anything. It's just a URL. It's just the web. So it's really an interesting pattern to follow. So people want icons on the home screen. Apple started with a crazy specific meta tag with Apple or Apple WebKit, I don't remember, to do that. So once you had the good tag, you can add something on the home screen. Google followed with some less specific tag. There wasn't Google in the name, but it was still non-standard. And once you had that on Chrome, you have to click on a menu no one clicks on. And then you have to look at the bottom just to click on Add to Home Screen. So nobody does that. And on Firefox, it's worse. It's in a second menu anyway. Once you have that, you can have a web app that was loaded in a browser, added to home screen, and that can be displayed in full screen. And we really have to think about it if we want real people, I mean, to install web app like that, because they won't click on that menu. So there's a last interesting spec to know about is the web app manifest. It's basically a JSON file where you can describe about your website, and you put a name, you put a huge list of icons because SVG seems too hard, and you put the start URL that will be browsed when you click on the icon. You can force the orientation, the display if you don't want browser Chrome and bars, and you can specify a background and a theme color so your URL bar is blue. So now you have that. Chrome has an interesting idea. Someone added a manifest and he has a service worker. It kind of looks like a web app. So I'm going to display a banner at the bottom saying, hey, do you want to add this to the home screen? That's how we are going to make normal people trying to view the web as another app store. And I'm really looking forward to Mozilla trying some other ideas regarding that. So what's next? With Service Worker, you have an independent thread in your browser. So you could, even if you have no pages open on your website, receive push messages and wake up a service worker, do some code, maybe open a notification, and if someone clicks on the notification, you could again execute some code that is in the service worker. And it works, actually, right now it works in Chrome. The spec is really moving a lot, so try it, don't ship it. But it's really interesting. Facebook implemented this a few months ago, so you can get rid of their native app. The web app is pretty great. Response streaming. It's really, really interesting. As you saw, I was forced to download the JSON in the service worker before going and sending it to the page. But with response streaming, I will be able to do streaming like I do in any proxy, any platform. So I take a little bit of data, I transform it, I template it, I don't know, and I give it to the page. So if I'm reading the documentation of Hibernate in, the full, the one document version, it's a pretty long document. I can really just be a proxy and a relay to the page and don't wait in the service worker. You'll also be able to do some synchronization. Imagine a cron-like syntax, and maybe I want to wake up my service worker every 15 minutes to make some updates on the cache. Don't be too smart. Browsers are already thinking about abuses, so it's also for that it's not really yet, but it's really interesting too. And the last one is geofencing. So if I enter an area local to my house, to my work, I could do some code and could notify someone and then could open a web page. So we'll soon have no longer technical excuses. We'll just have problems with user experience because it's really difficult to display something to someone on the web and hoping they will understand that this is not the more fresh version of the page. We'll have a lot of problems with data synchronization and conflict resolution. It's not a new problem in computer science, but it's not a solved problem for any case anywhere. So there's still some stuff to do. I hope you're convinced that the AppCache is a douchebag, that service workers are very promising. It really helps to bring the offline-first web and to close the native versus web. And I hope you'll help your Schrödinger's plans users to avoid the Jurassic Park effect. Thank you very much. I have 5 minutes for questions. Yes?
The Fetch API, can you use it also outside service workers? Can it be used outside?
So the question is, can you use the Fetch API in a web page outside a service worker? The answer is yes, and it already works in Firefox and Chrome and Opera. And it's a really good API to replace XHRs. So yes. If you have Twitter, you should follow these guys. Any other questions? Yes? Yes, I will, if you want. There will be the video on YouTube, but if you want the slides, yeah, I can tweet them. Yes. Okay, thank you very much.